Stupid TV screen. I'm gonna try to find pi over 6 and pi over 3. These aren't drawn terribly great, but I'm gonna try to find them. So this is at pi over 6. This is pi over 3. Okay. But to do this, I'm gonna have to call my friend Pythagoras to be able to do it. Let's see, draw a triangle. Okay. Let's say that that is pi over 3. Let's say that that is a right triangle. So I'm trying to get this triangle here. And of course, I can't draw it on the TV screen because it's broken. But I'm trying to get that triangle. So I have a right triangle, pi over 3, and a 90-degree angle there. Okay. Let's call this A. Let's call this B. Let's call this R. I know what R is because it's on the unit circle. Unit circle is x squared plus y squared equals 1. So we know what that is. We know that's 1. Okay. If I know I have a 90-degree angle, I have pi over 3. What is the missing angle? That's on my mind right now. And how am I going to find the location? This is the whole point. What is the x and y right there? And what is the x and y here? That's what we're trying to find. Pythagoras said that the sum of the squares is the hypotenuse squared. So this is a right triangle, so it applies. All right. But I don't think I can get it from there. I don't have enough information. I'm going to do a trick. And the trick is to get this stupid thing to work. I'm going to draw an identical triangle right there. Okay, which would also be 1. And would also have an A. So I have like a mirror of a triangle there. Pi over 3 is the one I'm looking for. I promise you if I can get pi over 3, I get pi over 6 for free, which is nice. So what does that mean? This triangle has to have the same angles as the other triangle, right? Right here, those have to be the same. Those A's, whatever that length A is, they have to be the same. Those two A's have to be the same. It's the mirror image of that. Okay. So in this case, since those have to be with the same angle, whatever that angle is, and those A's have to be the same, and if I have this big triangle with including the mirror image, I think those two A's have to add up to 1 as well. I think it's going to have to be an equilateral triangle. It's going to have to be the same. If that's true, then I have A plus A equals 1. 2A equals 1. A equals 1/2. If that's right, then a single A is 1/2. Okay, so then this is 1/2. Let's see where we are now. So if this is 1/2 and this is 1, this is 90 degrees and this is pi over 3, we haven't determined what that angle is yet. We have some unknown height. But Pythagoras is here for us. Okay. A squared plus b squared equals c squared. I know what c is, it's 1. I think a is 1/2, so I can solve for b. Okay, so a squared plus b squared is c squared. It is a right triangle. It has a 90-degree angle. I think a is 1/2, b squared, c is 1 squared. B squared equals 1 minus 1/2 squared, which is 1/4. So I have 1 minus 1/4, 3/4. Okay, b squared. B squared is 3/4. So what's b? If we take the square root of b, we know it's in quadrant 1, so it has to be positive. B has to be square root of 3 over 2. So I think that's the location of pi over 3. There's a question in the chat said, how did we find the value of 2a? Are we okay with the symmetrical triangle, the mirror image triangle? Was that okay? That part's okay? Okay. So I set whatever this value is, whatever that value, whatever this value is, I think they have to be the same. Because I want just a copy and then to invert the triangle. So I think I'll just call it A, whatever that length is. And then looking at this triangle, now the big one, now I have a big triangle. So I have this one. And I have pi over 3. I have pi over 3. I have 1, 1. Whatever this is 2a. And whatever this is, it's half of what I had before. And I think the only way this works is if 2a equals 1. Okay. I think it has to be an equal out triangle. I think it has to be 1. And if 2a equals 1, then 1a would be half. So a equals half. I think that's why a equals half. But if a equals half, okay, now we can start talking b. I think a is half. And if Pythagoras is right, c is 1, a is 1/2. So b squared equals 3/4. B equals √3 over 2. So that's the location of pi over 3. It's 1/2 root 3 over 2. All right, that's the location. I promise if we figured that out, we get pi over 6 for free. Okay, let's see how I do that. Let's see if that's even true. So this whole thing was to get the location of pi over 3. All right. What was this missing angle that I didn't talk about? A triangle has to equal 180 degrees or pi. That's half, right? So a triangle, 180 degrees equals pi in this world. Okay. The whole triangle, the right triangle at least, has to equal pi. Okay, it has to. I have a missing angle here. Pi equals pi over 3 plus pi over 2 plus, I don't know, somebody else. But it has to add up to pi, it has to add up to 100 degrees. Okay. So what's that angle? Who's this? Okay. So pi minus pi over 3 minus pi over 2 equals mystery angle. Well, let's figure out how we can do fractions. Let's make these a 6, I guess. I don't know. So I could double this to 6. That's 3, 6. And that'd be 6 over 6. Just doing the arithmetic. So this is pi over 6. The missing angle. Missing angle was pi over 6. So I said if we could do this, we get the location of pi over 6 for free. So you have root 3 over 2, 1/2, and 1. This is pi over 6. This is pi over 3. We only need to switch them, okay? We only need to switch them. This will become root 3 over 2, and this is 1/2. So we're looking at the angle, the other angle, top angle. We're looking at this angle now. So if we want to evaluate that, that's root 3 over 2 for the x and 1/2 for the y. It's inverted. Okay. We're going to see this a lot. We don't have to prove this again, but we'll see it a lot throughout the semester. So I claim we now have 3 positions in the first quadrant. Okay. So that's pi over 4, pi over 6, pi over 3. If you know those, it's symmetrical along the circle. So you get copies of that all around the circle. And those are the only ones we need to know for the course. Other than that, we can just use a calculator. Okay, let me check my time. We're okay. So I'm going to fill in the rest of the circle. Okay, I'm going to clear this.